All right, let's finish section 3.1. Okay, so let's suppose you have an ordered pair, but you don't have both numbers. You only have one number instead of the other. So you have an equation, I don't know, x plus y is equal to 10, and you only know one of the numbers. Let's suppose you know x. Let's see, x is 4, right? How do you find this other number? Well, what you're going to do is you're going to take your x and you're going to substitute it in for x and then solve for y. So whichever one you're given, you're going to substitute in and solve for the one that you don't know. So in this particular case, 4 plus y is equal to 10, and I would solve for y. In other words, get y by itself, and I would get y is equal to 6. All right, this right here is a very, very, very valuable skill to have. So please, please, please make sure you understand how to do this process, because you will be doing it a lot in this chapter. As a matter of fact, a lot in this school year. So please, please, please make sure you know how to do this. Okay, so we have this equation, y is equal to 2x minus 9. And I know the x value, but I don't know the y value. So I'm going to take my x, I'm going to plug it in for x, and then I'm going to solve for y, meaning get the y by itself. So 2, plug in 2 for x, minus 9, and I'm going to simplify this until I end up with y equals a single number. So multiply, I have 4 minus 9, and subtract 4 minus 9 is negative 5. Same thing here, only this time I have the y value instead of the x value, which is perfectly fine. We're just going to take this number and replace our y, and then solve for x this time. So we're going to add 9. And 2 times x, opposite of multiply is divide, and I get x is equal to 8. Now, the ordered pairs can be written in a couple different ways. We can write it as an ordered pair like this, but we can also have a table of values. I generally call it an XY table. XY table. So we usually write tables vertically like this, but depending on the situation, we could also write them horizontally. So I could have an XY table that looked like this. One of the advantages to writing it horizontally is when somebody's trying to type something, it's actually easier to type it this way than it is this way. Depending on the software that you're using. So you may see it like this if something has been typed up in some software or other. But anyway, just an FYI. You can see it frequently when I use my test generator software. So in your homework, you might see it like this instead of like that. All right, complete the table of values for the equation, write the results as ordered pairs. All right, so this time we're given a 0 for x. We're going to plug in our x. 0 minus 3y is equal to 12. You know that anything times 0 is 0. So I have negative 3y is equal to 12. 3, or negative 3 times y, opposite is divide. And I get y is equal to negative 4. And it also says write the results as ordered pairs. So this would be the ordered pair 0, negative 4. And repeat, this time I have a y value of 0. So we're going to do the same thing, and we're going to plug in 0 for y this time. Give ourselves a little bit of room here. So 2x minus 3 times 0. And anything times 0 is 0. 2x is equal to 12. Opposite of multiply is divide. And I get 6, so this is the ordered pair 6, 0. I'm going to give you a heads up. if I say pick any number to plug in and find a point, you're always going to pick 0 for x, because 0 is the absolute easiest number to plug in for x. It is also the absolute absolute easiest value to plug in for y. So if you have your choice of numbers to plug in, pick 0 for x, also pick 0 for y. All right. This time I've got 3. I'm going to plug in 3 for x. So 2 times 3 minus 3y is equal to 12. 2 times 3 is 6. And I need to subtract my 3 and divide by -3. And I get a y value of -2. So 3, -2 is my ordered pair. And then one last one. I'm not sure I have room here. Let me move the picture down here. Let's see. 2x minus 3. We're going to plug in -3 for y. And multiply a negative times a negative is +9. And subtract my 9. And divide by 2. Do not give me a decimal, and do not give me a mixed number. I want an improper fraction. 3/2 -3 would be the 4 ordered pairs. Okay, plotting ordered pairs. Let's talk about some, give you some definitions here. So if we have these are number lines actually, and this number that goes horizontally is the x-axis, and this number line that goes vertically is the y-axis, and they cross where they're both 0. This point right here where they cross, the name of that point is called the origin. And these two lines, they divide up this, it's called the rectangular coordinate system, into what are called quadrants. So we label the quadrants 1, 2, 3, and 4. Notice I'm going counterclockwise, and I label with Roman numerals. We always label the quadrants with Roman numerals. I don't know why, and we always go counterclockwise, starting in the upper right-hand corner. So quadrant 1, 2, 3, and 4. I already talked about this. This is called a rectangular coordinate system. I think I mentioned that. It's also called the Cartesian. Let's see if I can spell this correctly. Cartesian coordinate system. So I will use those two phrases interchangeably. The reason why it's called a Cartesian coordinate system is it's named after the guy who studied this and discovered it and wrote about it. His name was René Descartes. It's a French name, but I think he was actually Swiss. I think he was from Switzerland. And his last name is pronounced, it looks like Descartes is how it's pronounced. Descartes. The x and y axis determine a plane, which is a flat surface, similar to a sheet of paper, but in general, the plane extends infinitely. Okay. So the x-coordinate is going to give us our left and right. If it's positive, we're going to go to the right, and if it's negative, we're going to go to the left. And the y coordinate is going to give us our up and down. So positive would go up and negative, we're going to go down. So where those two meet, that's where we put the point. I occasionally will get a student that will put a point at 3, 0 and at 5, 0 to indicate the 0.35, and that is incorrect. So it's where these intersect right there that is going to give us the 0.35. I didn't mean to do that. This is what I was looking for. There you go. So over 3, up 5 is the 0.35. Negative 2, 6. My x is negative, that means go to the left. My y is positive, that means go up. So negative 2, 6 is going to be this point right here. 0, negative 1, go over 0, down 1. So here is my 0, negative 1. Negative 5, negative 2, go left 5, down 2. So here's my negative 5, negative 2. Positive 5, negative 2. So I'm going to go right 5, down 2. And 0, negative 6. So go over 0, down 6. This is a case where we have the table going horizontally. Complete the table of ordered pairs for the equation. Okay, it's very helpful to pay particular attention when they talk about what x and y represent. Okay, so make sure you read that part. It says x represents the year and y represents the number of twin births in thousands. Round your answer to the nearest thousand. Notice they didn't say thousandth. Okay, they only said thousand. Okay. So you guys are probably not familiar with rounding to the nearest thousand. So let me show you what that would look like. So let's suppose I had 245, 328. Just suppose I just made up this number. To round to the nearest thousand, okay, this is my thousand place. I would look the number to the right. If this is less than 5, we're going to keep this a 5. And if this is 5 or larger, we're going to round this up to a 6. So this number right here is smaller than 5. So we're going to keep this a 5. So 2, 4, 5, 0, 0, 0. This would be rounded to the nearest thousand. Okay. Clear. Now we're going to do this actual problem. 2007, we're going to take 2007, we're going to plug it in for x. Definitely want a calculator for this one. And 2989. All right, so plug this into our calculator. We have negative 1.421 times 2007. All right, I end up with 137.053. Okay, now, when it says this is the number in thousands, what that means is it's 137,053. So 137,053. But it also said round to the nearest thousand. So we are going to have 137,000. Okay, do the same thing for 2008. 2008 plus 2989. 421 times 89. All right, this time we get 135.632. So we want it, and this is in thousands again. Okay, so here's my thousands and round to the nearest thousand. So that means I'm going to take and round this up to 136. Okay, and interpret what that means. So in 2008, there were approximately 136,000 twin births. There you go. It doesn't say where. Maybe that's worldwide. Not sure. Okay. So